Hello and welcome to my series of videos on number theory. So when is a number divisible by 4? So the rule for divisibility by 4 is similar to 2, but with a few extra conditions. So all even numbers are divisible by 2, but only half as many are divisible by 4. No surprise that 2 over 4 equals a half, 1 over 2. So all numbers divisible by 4 are even and live in the arithmetic progression 4 times 1, 2, 3, 4, 5 equals 4, 8, 12, 16, 20. So that's an arithmetic progression. First term 4, common difference 4. That includes every single number that is divisible by 4. They all appear exactly once, none are left out. Now there's a clever rule which says that if the last two digits are divisible by 4, then the number is divisible by 4. It's very handy because it means that for long numbers we can only have to check the last two digits. Example 17345627722812. So the last two digits here is 12. So I can tell you immediately that this number is divisible by 4. Because 12 in the end and 12 over 4 equals 3. Now this works because we rewrite the number in the form x equals 100a plus b. So the 100a, so a will be 17345627728 and our b will be 12. So a and b are integers. So x over 4 is equal to 100a over 4 plus b over 4. So x over 4 equals 25a plus b over 4. Now since a is an integer, then 25a is an integer. So we only require b over 4 to be an integer, and b was 12. So b over 4 equals 3. So we're done. However, the drawback is you need to memorize or know all of the numbers from 1 to 100, which are divisible by 4, and have at most two digits. So i.e. 4 up to 96. So now I'm going to show you a more general rule for checking divisibility by 4. So let's consider the arithmetic progression again, which contains all numbers divisible by 4. 4, 8, 12, 16, 20, 24, 28. Again, you'll notice they have a common difference of 4. That's no accident. And we can split this in such a way that if we put all numbers that have the same last digit into one group. So the last digits are 4, 8, 2, 6 and 0. So we put all the ones ending in 4 together, all the ones ending in 8 and so on. And you'll notice they all have a common difference of 20. Each set has a common difference of 20. When I say set, I mean arithmetic progression. Why does it have a common difference of 20? Well, the full set has a common difference of 4. And we are splitting it into 5 subsets, 5 equal subsets. So the common difference is therefore going to be 4 times 5, 20. So that makes perfect sense. And you can verify that they all have a common difference of 20, these sets. So if you look at the first one, ending in 4, 4, 24, 44, 64, 84, you'll notice that if it ends in 4, then the number preceding that is even. You've got 2, 4, 6, 8. If it ends in 8, again, the number preceding it is even. The second last digit is even. If it ends in 2, the second last digit is odd, 1, 3, 5, 7, 9, etc. If it ends in 6, the second last digit is also odd, 1, 3, 5, 7, 9. And if it ends in 0, the second last digit is even. So they're obviously even with ending 0, 2, 4, 6 and 8. But you'll notice the ones ending in 0, 4, 8 are all preceded by an even number, and those ending in 2 or 6 are preceded by an odd number. And this holds in general. So if the number ends in 0, 4 or 8 and the digit preceding it is even, then the number is divisible by 4. If the number ends in 2 or 6, the digit preceding must be odd. So to summarize, the rules are 1, the number must be even. 2, if it has a last digit of 0, 4 or 8, it will be preceded by an even digit. And if the last digit is 2 or 6, it will be preceded by an odd number or odd digit. So the beauty of this is that we don't need to learn our 4 times table. Example, 1, 2, 4, 8, 4, 8, 2, 9, 9, 3, 8, 0, 2, 9, 7, 6. Now quite clearly you can see the 76. It's just sticking out, glaring at you. Now if you apply the old rule that I looked at earlier, you can see that 76 divided by 4 is 19. So you can quickly verify it's divisible by 4 using that rule. However, we're not going to use that rule this time. We're going to use the new rule that I just showed you. It's divisible by 4 because the last digit is 6 and the preceding digit is odd, the second last digit, which is 7. Now if that wasn't odd, if that was say even like 6, so that was 60, so that would be 66 or 86 or whatever, then it wouldn't be divisible by 4. Okay, so we're not using the fact that 76 is divisible by 4. We're using the fact that the last digit is a 6, and the rule for 6 as your last digit means that the digit before it must be odd. And as I said earlier, the beauty about using this approach is that you don't need to learn your 4 times tables. You just need to know the parity of the digit. So let's prove it from an arithmetic approach. So if the last digit is 2 or 6 and the preceding digit is odd, then x is of the form 10 times 2y plus 1 plus 2 or 6. X is equal to 20y plus 10 plus 2 or 6. X is equal to 20y plus 12 or 16. And then we check if it's divisible by 4. You divide across by 4, you get x over 4 equals 5y plus 3 or 4. So our two solutions, possible solutions, will be 5y plus 3 or 5y plus 4. And they clearly work because y is an integer. So y is any integer from 0 to infinity. Where does that come from? It comes from the 2y plus 1 at the top. So you plug in y equal to any number from 0 to infinity, and that generates an odd number. So this is how we set the equation up. So it's 10 times an odd number plus 2 or 6. So this will be our last number. So when you're looking at the second last number, you need to multiply by 10. Similarly, if the last digit is 0, 4 or 8 and the preceding digit is even, we have x equals 10 times 2y plus 0, 4 or 8. Notice I'm multiplying by 2y this time, not 2y plus 1, because we need even number there. So that x is equal to 20y plus 0, 4 and 8. So divide over by 4, you get x over 4 equals 5y plus 0, 1, 2. And the 0, 1, 2 clearly comes from 0 over 4 equals 0, 4 over 4 equals 1, and 8 over 4 equals 2. And then in the other case it was 12 over 4 equals 3 and 16 over 4 equals 4. So all these numbers are divisible by 4. Now I suppose the critical part is that this number, the coefficient of y is 20, so that has to be divisible by 4 or the whole thing breaks down. So that means we have 5 possible solutions. We have 5y plus 3, 5y plus 4, 5y plus 0, which is just 5y, 5y plus 1, or 5y plus 2. And they're all integers because y is an integer. So thanks for watching. Please subscribe and I'll see you on the next video.